Welcome back. Welcome to this brand new section on collections. We will start this section with a question. Why do we need collections? Let's look at that in this specific step. In the previous sections, we talked about arrays. We talked about the facts that array is a fixed length, right? So once I create an array with a specific length, I cannot change the length of an array. So here we have an array of 15 elements, index runs from 0 to 14, and let's say I would now want to insert a new element 100 at the index 2. So at this location I would want 100 to be inserted. What I would need to do is to write a lot of new code, right? I would need to write code to create a new array with 16 elements. After that, I would need to copy the first two elements and then insert the new element 100 into it. And after that, I would need to copy the rest of the elements. That's a lot of work. And that's what ArrayList does for you. ArrayList is a collection. Similar to array, there are a lot of other data structures how you can store your data. Linked list, hash table, tree. The question Java asks you is, do you want to focus on the low level data structures or do you want to focus on your business logic? And Java also provides a solution for that. Java provides a number of built-in collections. Some of the important collection interfaces that Java provides are list, set, queue, and map. You can use these collections to solve a wide variety of problems. In the next steps, we would learn about each of these collections, what are the different variations that are present with each one of them, and how do you choose the right collection for the right problem. In this video, we looked at why we need collections. The underlying data structures are very complex. Even inserting a simple thing into an array or deleting a simple thing involves writing a lot of code. Other data structures like tree, linked list are even more complex. Java provides implementations of these data structures called collections. So you can focus on the business logic and don't really need to worry about what's happening beneath them. What we would need to get is a good understanding of each of these collections and what is the data structure underneath it and when is the right time to use which collection. We'll focus on those questions in the subsequent videos. I'll see you in the next step. Welcome back. In this video, we will start talking about one of the basic collection interfaces, list. We talked about list in a previous section, so this is like a quick revision of whatever we have learned about list and ArrayList in the previous sections. If you would want to find the documentation for any of the interfaces that we are going to discuss, all that you need to do is type in Java 9 and type in the name. Type in Java 9 and list. You can pick up this one. Always take the latest version of the documentation because there might be a lot of changes between versions of Java. So what we are picking up is the Java 9. So you can see Java SE9 list. Once the page loads up, you can see a lot of information about the list interface. If you scroll a little bit down, then you would see all the important documentation about the list interface, right? Important statement is this is an ordered collection. That means you have precise control over where each element in the list is inserted. What does ordered mean? That means you can actually insert elements at a specific position. So you can say I would want to add an element at a specific position. I can get elements from a specific position. The other important thing you see in here is lists typically allow duplicate elements. And it also says list interface provides 4 methods for positional access to list elements. I would recommend you to spend some time looking at the list interface documentation. Over here you would be able to find out what are the super interfaces of list. That's basically what are the interfaces list is extending, and also the sub interfaces, what are the other interfaces which extend list, and also you'd be able to find what are the implementation classes. So which of the classes implement the list interface. You would also find the details of each of the methods that are present in the list interface, and also the other methods which inherits from other interfaces. Now, here is the important summary about a list interface. The most important thing about a list interface, it really cares about which position each object is in. You can add elements by specifying a position, saying, okay, I would want to add an element in 6th position. I can add an element in 10th position. You can also add elements without specifying a position, and then it is added at the end, right? So this is a lot of boring theory. Let's get started with the interesting part. Let's do the hands-on now on the list. I'm in JShell, I've launched it up, and now let's say I would want to create a simple list. So I would want to create a list which can store string values. How can I create that? I can say list of string. This is a generic saying this list would hold string values, and I would want to give this, let's say we are going to play with a list of words, and I would want to create a new list. The easiest way to create a new list in Java 9 is say list.off. So off is a static method which is present inside the list interface. So I can use this and I can create apple, bat, and cat, and semicolon. So this is the easiest way to initialize a list with a set of elements. What we are doing in here is we are using a static method called of list of apple, bat, cat. Isn't this awesome code to read? In earlier versions of Java, it was not possible to do as simple as this. You had to create a new array list or something of that kind and then add each of these elements. Or you had to create an array and then try and convert it to an array list. This is one of the awesome features which I love from Java 9. Similar methods are available in other programming languages as well, and Java now has picked it up, right? So this is cool. Now, from these words, I can get all the details, right? So if I want to get how many words are present in this, so it's a length method. Oops, length is what is used on a array, right? So it's in ArrayList, it's size. In collections, it's always size. In arrays, we have a length property, and in ArrayLists or collections, we have size. Size is used to find out how many elements are present inside your collection. There is also a method to find out is it empty. So is this list empty? Nope, it isn't, right? So it returns false back. You can also get the element at a specific index. As we read in the documentation, the index starts with 0. So this is 0, this is 1, and this is 2. So all that we need to do is say words dot get of 0. What would it print? Apple. So this is the way you can access a specific element from a list. Now I would want to find out if an element is present in this list or not. What can I do? I can use a contains method. So I can say words dot contains dog. Does it contain dog? Nope, it doesn't. Does it contain cat? Yes, it does. List provides you a lot of simple methods to find out details about what is present inside the list. Let's say I want to find out where the cat is present. So I can use index of cat. So I'm trying to find out where cat is present, right? So it's present at location 2, right? So if I print words, this is 0, this is 1, and this is 2. So index of cat is 2. If you try and find out the index of something which is not there, what does it return? -1. So when it returns -1, it means that the word is not present inside the list. In this video, we started with creating an implementation of the list interface, and we played with different methods which are present in the list interface to retrieve details about what is present inside the list. I'll see you in the next step. Until then, bye bye. Welcome back. In the previous video, we created a simple list and we tried to get the details about what is present inside the list. In this video, we would start exploring a fact called a immutable list, and also we would talk about some of the ways you can create mutable lists. Now, what is immutability, mutability, and all this fun, right? Let's start with that, right? So we talked about the fact that string class is immutable. We talked about the fact that the big decimal is immutable. Wrapper classes are immutable. What does that mean? That means that once you create an instance of that specific class, you cannot change the value of it. Similar to that, anything that you create using the off functions, list.off, or later we would be talking about map.off. Anything you create with these functions, it's a immutable list. So now into this list, I cannot add anything. So if I say words.add dog, what happens? It kicks me out. It says unsupported operation exception. It's throwing an exception saying whatever you're trying to do is not supported on this specific list. Now, if you want to create mutable lists, the options are either I can create an array list, or I can create a linked list, or I can create a vector. Now, you might be asking, how can I create an array list? How can I create a linked list based on these words? It's very easy, right? So if I want to create an array list of the words, what I need to do is I need to say words array list. Let's say that's the name I'm giving it. Words array list is equal to new array list and say words, right? So I would also want to say this an array list of string. So I can say list of string words array list is equal to new array list of words. Now this becomes a array list. So now I can modify values in it. Similar to this, actually, if I want to create a words linked list, I can do this as well. New linked list. And similar to this, you can also create a vector. So you can say instead of this vector, and this would be a words vector. The great thing about creating an array list, linked list, or a vector is you can add values into it. So words array list dot add, let's say I would want to add in dog. It's allowed. And now if I print words array list, you'd see all the contents. So words array list, now you can see that dog is added at the end. And similar to this, we can add values to words linked list and words vector as well. Now you might be asking, when do I use array list? When do I use linked list? When do I use vector? How do I choose between them? The other question might be, what are the other operations, other modification operations that each of these lists support? We talked about add. What are the other operations that are present? We will discuss about those things in the next steps. In this video, we looked at the fact that anything that you create with list of is a immutable list. You cannot change the data. And if I want to create a mutable list, I would need to create an array list, linked list, or a vector based on this data. We saw that we were able to execute an add method on this. I'll leave it as an exercise for you to play with the linked list and the vector. So words linked list and words vector, try and add values to it and try and see what's happening with them. Try and play around with them, and I'll see you in the next step where we would start discussing about array list versus linked list versus vector. Until then, bye bye. Welcome back. In the previous step, we created instances of ArrayList, LinkedList, and vector as well. In this video, let's try and understand what is the difference between an ArrayList and a LinkedList. Now, let's start with the basic data structure which is used underneath this. Underneath ArrayList, the basic data structure which is used is an array, and same is the case with an vector. However, with a linked list, the data structure which is used is a linked list. What does that mean? Let's look at a picture. So this is an array. Underneath an array list or a vector is an array. Underneath a linked list is a data structure called a linked list. We talked about array earlier, right? So in an array, the values are present next to each other, and therefore I would be able to get a specific value at location 8. If I want to get it, I can get it very fast. However, with an array, inserting values and deleting values is a time consuming operation. If I want to insert an element here, then I would need to move all the other elements one step to the right and insert a new element in here. I would also have to create new arrays in certain situations. If I have to delete 50, then I have to delete this and move all the elements to the right one step to the left, right? These are costly operations because there are multiple elements that I would need to move up and down. The other kind of data structure is a linked list. In a linked list, you have a reference from one element to the other element. So the way elements are stored, if I'm storing 6 elements like this, is I would have a link from 45 to 25, 25 to 4, 13 and 6. So if I want to find the 5th element in a linked list, then I have to start from here and say first element, second element, third element, fourth element and 5th element. So trying to access something from a linked list is very slow. But if I would want to delete an element from a linked list, let's say I would want to delete 6 from the linked list, then all that I would need to do is delete this element and change the next value of 13 to 5. So change the link, 13's link would change to point to 5. Or if I would want to add a element in between, so between 45 and 25, let's say I would want to insert 100, then I can change the link from 45 to 100 and 100 to 25. So the important thing is to understand that the underlying data structure beneath a array list and a vector is an array, and beneath a linked list is a linked list. For an array, insertion and deletion are costly, and accessing a value from the array is very fast. For a linked list, inserting an element and deleting an element is much more easier than an array, but accessing an element at a specific location based on the index or trying to search through the linked list is a little more costlier. Trying to find an element at a specific index is a much more costlier operation with linked list because you have to go through an element by element. In summary, array list insertion and deletion are slower compared to a linked list, and it allows a constant time access. However, with the linked list, elements are doubly linked. In the picture we saw only the forward link. Actually, in the linked list implementation in Java, we use something called doubly linked list. That means you have a link forward and also a link backward. So you have a link to the forward element and the backward element as well. As we discussed, iterating through a list is very slow because you have to move from one element to another element, and also accessing a specific element is slower. So if I want to access 5th element, it would be faster in an array list compared to a linked list. However, linked list would have faster insertion and deletion. So think about when you would use an array list, when you would use an linked list. When you have very few insertions and deletions, very few modifications in the list, and you would want to access the elements based on their position, you would go for an array list. If you have a number of insertions and deletions, then you would go for your linked list. In this video, we tried to understand difference between an array list and a linked list. We looked at the underlying data structure beneath the array list and a linked list. We saw that the underlying data structure beneath an array list is an array. Linked list is a doubly linked list which has a link to the forward element and the backward element. We also discussed the right problems where you need to use array list and linked list. In the next video, we will move on to the next step. Until then, bye-bye. Welcome back. In this step, let's discuss the difference between a vector and an array list. We understood the difference between linked list and array list. Now, when did you choose a vector? When did you choose an array list? If you look at the vector class, it's present since Java version 1. So it's present from the first version of Java. However, ArrayList class is only present since Java 1.2. So ArrayList came later. Before that, whenever you wanted to use a list, you had to use a vector. Now, what is the problem with a vector and why did ArrayList come into picture? Let's see the difference between the code. Let's pick up a couple of methods from ArrayList and the vector classes. So trim to size, for example, in vector is synchronized. However, in ArrayList, it's not synchronized. If you look through all the other methods, you'd see that there is synchronized on most of these. However, when you get to the ArrayList, you'd see that there is no synchronized on these specific methods. What difference does the synchronized keyword make? Let's say you have 25 synchronized methods in a class. What happens is if this instance of this class, if an instance of the vector class is shared between multiple threads, then only one of those threads can be executing any of these 25 methods. So at a particular point in time, only one thread can be executing any line of code inside these synchronized methods. Why do you want to do that? Because you want your programs to be thread safe. The behavior of your program should not change when you are accessing it from one thread or 15 threads. And that's what synchronized tries to do. We looked at what is the fundamental difference between a vector and an array list. The important difference is that vector, all methods are synchronized. That means vector is thread safe in the sense that you can use vector in situations where you are sharing data between multiple threads. However, ArrayList is not thread safe. One of the things you need to always remember is thread safety does not come free. It has a performance impact because when one thread is executing a piece of the synchronized method, then other threads might be waiting for that thread to complete execution of the synchronized method. Unless you need thread safety, you would go for an array list. If you would want thread safety, then vector is one of the options that is present. Synchronize is one of the basic ways to implement thread safety. There are a number of approaches to thread safety that have evolved in the last decade or so. And Java also provides those options. Those are called concurrent collections, and we would look at concurrent collections after we look at threads and thread safe. For now, vector is the most basic option to provide synchronization to make sure that your code is thread safe. If you don't worry about thread safety, then you can go for an array list. That's the main difference between a vector and an array list. I'll see you in the next step. Until then, bye-bye. Welcome back. In the previous steps, we discussed the difference between ArrayList and LinkedList. We talked about the difference between ArrayList and vector. In this step, let's focus on all the different operations that you can do on these lists. In the first steps, we discussed how to get the data from a list, and we discussed the fact that by default, the list which we create using list.off is a immutable list. So we cannot change the data. So we discussed what are the three ways you can create array list or linked list or vector. Now, in this video, we would be using the words array list to play with the array list and insert data into the array list. However, the same operations you can either do on a linked list or a vector. These operations do not really change based on the implementation of the list which we use. Let's use the words array list and play with it. If I want to add an element to the array list, the way I can do that is by saying words array list dot add, let's say elephant. So this is how you would add an element. You can also add an element at a specific index. So let's say I would want to add it at position 2. I would want to add ball. Now you would see words array list has ball at index 2. So you can add elements at the end or in between at a position of your choice. The important thing about an list, this is common to all the lists, is a list can have duplicates. So if I say ArrayList.add ball again, I'm not specifying an index this time, you can see that this is added in. You can see that it is added at the end. So you can have the same element present twice in an array list. Array list allows duplicates. Let's say I have another list which is present and I would want to take all those elements and add it into this array list. So let's create a simple list, right? List of string, new list, and let's say this is list.off, and let's say this is storing yak and zebra. Now let's say I'd want to add all the elements of this list to this list. How do I do that? I can do that by words ArrayList dot add all and pass in the collection. So the collection is new list, right? So that returns true. And if I print the content of the words array list, what would you see? You'd see yak and zebra at the end. Actually, you can also specify a position. So if you put add all to new list, then all the elements would be inserted starting position 2. Until now, in this step, we were looking at all the operations to add elements to a list. You can either add single element, you can add an element at a specific position, or you can add a list of elements to an existing list. Now, let's look at operations to modify the data which is present in the list. Let's say I would want to change the element at this index 1, 2, 3, 4, 5, 6, 7. Actually 0, 1, 2, 3, 4, 5, 6. So at index 6, I would want to change the element. So I don't want a ball, but let's say I would want to have a fish because ball is out of place in here, right? So let's say I would want to put a fish in here. How do I do that? I can say words ArrayList dot set 6 comma fish. So what would happen is the element ball would be removed and its place we would have fish. So if I print the array list right now, you'd see fish in here instead of the ball. So this is how you can change the element that is present at a specific position. The last set of operations to modify are involving deletion of elements. You can delete elements from an array list in two different ways, based on the index and based on the element itself. So let's say I would want to remove the element at index 2. What would happen? It will remove the element. So if I print the words array list right now, you'd see that ball is not really there. So what is happening here is remove 2 is returning us the element and it removes the element from the array list. The other option to remove an element is by specifying the element directly. So I can say remove dog. Then the first instance of dog would be removed and it returns true. So it says, now if I print the list, you'd see that dog is not really here. Now if I try to remove an element which is not there, so in the existing list dog is not there, so it returns false back. So it says, okay, I'll try to search for a dog, but it's not really there, right? So in this small step, we looked at all the modification operations that you can do on a list. We started with adding elements into the list. We looked at methods to change the element at a specific position, and we also looked at methods to remove elements from the list based on index as well as the element itself. I would recommend you to play with these operations again. We were using an array list, so I would recommend you to create a vector and also a linked list and try to play around with these operations. Another exercise I would recommend you to do is to create 3 different lists and try to create a list merge of all the 3 lists. So create lists called list 1, list 2, list 3, and create another list called merge list with all the elements in list 1, list 2, list 3. So those would be the 2 exercises for this specific video. I'll see you in the next step. Until then, bye-bye. Welcome back. In this video, we would look at the different ways you can iterate around the array list. I would want to loop around this array list and print all the values which are present in it. How do I do that? That's basically the focus of this video. One of the ways you can do that is typical for loop, right? So I can say for I is equal to 1, do we know the length of the array list? Right, we know that, right? So words dot size or length, it's size, right? So for any collection, it's size and I plus plus, and I can say system dot out dot println words dot get of I, right? So it gets the value at index I and prints it. So that's the most basic way, right? There is also an enhanced for loop, right? So you can say for string word in words, I would want to do a system.out.println of word, and so it exactly gives the same result. So this is the basic for loop. This is the enhanced for loop on a list of string. Other than this, lists also provide an iterator. So you can say iterator, words iterator is equal to words dot iterator. So iterator is another way you can actually iterate around a list. In this approach, we would need to use a while loop. So while words iterator dot has next. So this is one of the methods which is present in the iterator interface. While there is an element present in the words dot iterator, what I'll do is I'll try and loop around it. So println. Now I would want to get the next element. How do I get that? So it's words iterator dot next. So this would give me back the next element, and I can go ahead and close the loop. Now you'd see that the same output happens at apple, bat, and cat. So while there are elements to iterate around, while words iterator has next, let's go ahead and do a next, and we print that element in here. In this video, we tried to learn about how to iterate around arrays and print the values which are present in there. So we discussed 3 different ways of doing that. As an exercise, you can try creating an array list with integers. So try and create a list with integers and try iterate around it using all these 3 approaches. I'll see you in the next step. Until then, bye-bye. In the previous step, we discussed about the 3 ways of iterating around the list, right? Why do we have 3 different ways of iterating around the list? Why do we need them? That's because in certain operations, you'd want to use a specific kind of looping. In this video, let's look at what kind of operations you should use what kind of a loop. Let's go ahead and recreate the list. So now we have a words list, and let's actually create an array list as well. So words, I'll call this words AL, array list, or AL. I'll keep it at small. So words AL, which is array list, and this array list I would want to create it based on the words which were created earlier, right? So how do I do that? I can do that by using new array list of string and specify the words. Because we are specifying the type of what it has on here, I don't really need to specify it in here as well. So I can actually remove this. This is one of the new features in Java. So you don't really need to specify the type on both the sides. So this is a list of string. So here it can infer that this is a list of strings. So I can do this. So now we have a words array list, right? So we have words and we have a words array list. Now, if I would want to loop around the list and I would want to print those words which are ending with AT, how can I do that? The easiest way would be to just go with the enhanced for loop, right? So string word from words. Because we are not making a modification, I can use the list. That should not be a problem. And I can say if word dot ends with 80, then I can say system dot out dot println the word and close the loop, right? Aha, I made a syntax mistake. So let's see where it is over here, right? And let's fix it. Okay, it's printing bat and cat. That's cool, right? So we are able to loop and print the values based on a specific logic. This is cool. If I have to do the same thing actually with an iterator, I would need to write a lot of code. So in these kind of situations, for loop might be preferred. We would actually discuss a better way of doing this using streams when we talked about functional programming and lambdas a little later. For now, with whatever we know, this is the best approach, bat and cat. So we loop around using a enhance for loop and we print the values out. Now, if I would want to actually delete all the values which end with 80, can I use a enhance for loop? Let's check that out right now. So string word, because I would want to modify the list, I'm going to use an array list, right? So you cannot modify the default list.off because it returns an immutable list. We created an array list of words AL, and that's what I'm making use of in here. So words AL, and the logic we would need to write is if word dot ends with 80, then what do I want to do is I would want to remove words dot remove word, right? So I'm trying to remove the word. Let's close the if and close the loop. Oops, I made a mistake. I should have actually had words AL in here. Let's fix that right now. So words AL, words dot ends with 80. I would need to actually remove it from words AL. I'll not be able to modify the words, right? So I need to print words AL. And now let's see what's in the words AL. You'd see that it has apple and cat. We tried to remove all the things which had at in there, but you'd see that cat is not deleted. Why? The reason is that when you're using an enhance for loop, in the middle of the loop, it is not recommended to make modifications, especially deletions from the list, because you are removing a word from that specific list and it might change how the iteration happens. In these kind of situations, it is recommended to go with a iterator. So if you want to remove an specific word from a list, the best approach would be to use a iterator. Let's see how we can do that. Let me reinitialize the list again. So I've reinitialized the list again as a list of apple, bat, cat, and word al. Words al is new array list of words. Now I would want to delete everything that is ending with 80. How can I do it with an iterator? So the way I can do that is iterator. We would want to iterate strings. So iterator of string, iterator, we can use words al dot iterator, right? So now we get the iterator, and now we can use the iterator to loop around. So while iterator dot has next, what do we want to do while it has an element? If iterator dot next element, what do we want to check on the iterator dot next element? We want to check if it contains or ends with, actually, if it ends with 80. What do we want to do if it ends with 80? What do you want to do? We would want to remove it. So how do I remove an element from an array list using an iterator? there is a method for it. So iterator dot remove. Now I can go ahead and close the loop and press enter. You can see that this has got executed, and if I now look at words array list, you'd see that there is only one word in there. It's apple. Bat and cat are deleted. So in this video, what we were looking at is how do you make a modification in between a loop to an array list. The best way to do that is by using a iterator. So iterator is the best way to delete. If you're just looping around it, then probably an enhanced for loop is the best way to go with it. However, if you are trying to make a deletion or something of that kind, then it's better to go with an iterator. It's safer to go with an iterator. I'll see you in the next step. Until then, bye bye. Welcome back. We are learning a lot of things around list, array list, vectors, linked list, and a wide variety of collections. In this step, we will focus on a few puzzles with lists. Let's say I just create a simple list, right? So I'm creating a list saying list values is equal to list dot of, I'm saying a, then I'm putting a character a, then I'm putting 1 comma 1.0. What do you think will happen? What do you think will happen? So I'm actually creating a string, a character I1 and 1.0. What will happen? Okay, it's actually creating the list. And if I actually try and do value.get of 2, what would happen? It would print 1. If I do an instance of and try and check what is the instance of, whether it's an instance of integer, it's printing true. So what is getting created in value.get2 is not an int, it's getting an integer. What is happening in here? Let's try to understand in depth, right? One of the important things is in a list, you cannot store primitives. So here I'm trying to store a character a is a primitive, 1.0 is a floating point constant. Now, what is happening? How am I able to store it in? Think about it. We learned something when we were talking about wrapper classes. That's the concept called auto boxing. What happens when I'm trying to create a list is all these get auto boxed and a wrapper class gets created. So for this one, the wrapper class is integer. For the character A, the wrapper class is, think about it, what was it? It's character. And for the last one, which is value.get3, it's an instance of, by default, floating point constants are double. These is a character. Now it's autobox to a character. This is autobox to an integer, and this is autobox to a double. And here we are creating a list of a variety of values: string, character, and integer and double. If I don't want to allow that from happening, if I want to allow my list only to have specific kind of values, that's where generalization comes into picture, generics. So now what I'm doing is I would want to only store list of string text values. Now what would happen? Obviously it would fail because now I'm trying to store, you can see what is it saying? I'm trying to store a double, a integer, a character. These are not allowed inside a string. So if you are actually saying list of string text values is equal to list of something, then you can only store string values into this list. You cannot store values of other type. When we discuss about generics a little later, we'll understand how to create methods and classes that use generics. For now, the way you can understand it is if I say list of string, I can only store string values in it. And the other important thing is inside a list, you cannot store primitives. Everything gets auto boxed. Let's try and create a list of numbers, list of integer, and let's call this numbers is equal to list of a set of numbers, right? 101, 102, 103, 104, and 105. So let's say this is a very simple list, right? Now in this numbers, if I do an index of 101, what do you think will happen? Index of 101, what would return? It says 0 because it does a search using this 101, it boxes it and finds the element and returns the index as 0. Now I would want to take this and I would want to create an array list because I would want to modify the values inside this. So let's go ahead and do that. List of integer, and I will say numbers as usual al is equal to new array list. I don't need to specify the type. We learned y in the previous video. Numbers. What would it happen? It would create a new array list with these numbers present, right? So now, if I say numbers al dot index of 101, yeah, there's no change. It returns 0 because that 101 is present in this place. Now, if I want to remove number 101 from this list, can I say numbers al dot remove 101? Oops, it says index out of bounds exception. It says index is out of bounds. Why is it so? What is happening with the index of method is there is no overloaded method for index of. There is only one method which accepts a object. So what is happening is this 101 is getting auto boxed into an integer and you are searching for integer. However, when we look at the remove method, if you look at the remove method, if I press a tab right now, you'd see that there are two remove methods, right? So there are two remove methods, one accepting an object, the other one accepting an index. And when I say 101, what happens is instead of using this method and converting this in 101, autoboxing 101 to a integer, what it does is it matches with this method and it uses 101 as the index. So if I want to remove element 101, I would need to say integer dot value of, so I'm creating an integer and then I'll be able to remove it. I could have used new integer of 101 as well, but as we learned in the wrapper classes, integer dot value of is much more efficient. Now if I do numbers al, you'd see that 101 is removed. Okay, in this video we looked at a few random puzzles related to lists. We tried to play around with the list, try to understand them a little more. If you were not able to get a few parts of it, that's okay. The idea was to just dig a level deeper than what we usually do and try to see what's happening. Let's get back to the usual stuff in the next step. Until then, bye-bye. This video is part of a Java course with more than 250 steps helping you become an expert on Java. You can find the complete course details in the description of the video. Along with it, you can also find the details of a free PDF with 200 pages of awesome code examples in 28 minutes, creating great programmers.